Hello everyone, I'm Ariel and I'm the environmental engineer for the project. I worked with Varun and Natalia to create the optimal ranges of the environment within the terrarium, and I worked with Michael to create the physical body and humidity system of the terrarium.
Hello, my name is Gabriel and I worked on the market research of the
Hey, my name is Renan Jose, and Dan and I worked at the schematic for the whole system.
Earth's orbit, Mars, the Arctic, mountainous terrain, the ocean floor, the deserts, and the moon, all places we have yet to explore. But there's a problem. These locations are not ideal to grow food. It's also very expensive to transport to these remote locations. According to NASA, today it costs $10,000 to put a pound of payload in Earth's orbit, not to mention the moon or Mars. Locations such as mountains, deserts, the Arctic, and the unexplored ocean floors lack the infrastructure to ship food regularly. Plants require a controlled temperature, humidity, soil pH, soil moisture, soil composition, and light to grow efficiently. Houston, we have a solution. The global space economy continued to grow last year and reached $423.8 billion, according to a report by the Space Foundation. Products determinants include smart terrariums or greenhouses and indoor farming companies. Our goal is to design a product that contains and recycles as much material as possible while preventing bacterial or fungal infections. While doing market research, we found that on Google Trending, indoor gardening also began to trend and has remained at higher levels than before the pandemic began. We then decided to do some market research with a form to see if partners would be interested in the automated terrarium. So we posted a Google form on gardening social media platforms, including Discords and Reddit. And when we asked, do you currently have a garden? 62% of respondents said yes. When we asked, are you interested in indoor gardening? 95.8% of respondents said yes. Do you currently own a terrarium? 83.3% of respondents said no. Do you ever forget to water your plants? 66.7% of respondents said yes. Would you be interested in an automated terrarium? 29.2% of respondents said yes, and 54.2% of respondents said maybe.
Model of our terrarium. The frame in light blue will be made of T-slotted framing rails. The purple is the chassis for the humidity system. The green is the boots for the ducts, and so the boots will allow us to easily transition from the glass to our ducts while still maintaining a seal. The red is our electric system. We have an Arduino, AC/DC converter, a voltage regulator. Way up there we have an air temperature and humidity sensor, and then right here we have a soil moisture sensor. This will be below the height of the soil. So our chassis for our humidity system will house a blower and condenser coil. Our T-slotted framing rails will have glass slid into them. Between the T-slotted framing rail and the glass on the inside, we'll have a natural rubber gasket. Between the glass and the T-slotted framing rails on the outside, we'll have silicon. So the determinants will monitor and control soil pH and moisture, humidity and air temperature, light exposure. This will allow researchers to focus on their work rather than their food supply. The third scale prototype, you can see here our various soil layers. At the very bottom, we have pebbles. On top of that, we have activated charcoal. And then on top of that, we have peat moss. All of these layers will only be 2 inches deep. However, our soil layer will be 12 inches deep. Our water condensed from our humidity system will be run down into our pebbles layer, where it will absorb upwards through the activated charcoal and peat moss to water the soil without increasing the humidity of the system. We chose activated charcoal because it's frequently used in water filters, and we wanted to prevent bacterial growth. The peat moss keeps the activated charcoal separate from the soil, which is important because we don't want the plant's roots touching the activated charcoal at any time, as that would likely kill the plant's roots. The soil will be loam, and we'll use 10-10-10 fertilizer in this terrarium. The ideal environment for kale. So during seeding, we're going to aim for soil temperatures over 75 degrees Fahrenheit until the seed germinates. After transplantation, our air temperatures will be around 60 degrees Fahrenheit. However, for the remaining growth of the kale and the environment that the terrarium will remain in for most of its use, we are aiming for a minimum of 55 degrees and a maximum of 75 degrees Fahrenheit. However, our optimum temperature range is 60 degrees to 70 degrees Fahrenheit. But our most important factor is our humidity range. This is our air humidity, by the way. So we want between 40 and 60% air humidity. However, should we need to alter the temperature, so go a little below 60 degrees or a little above 70 degrees Fahrenheit in order to keep our humidity below 60%, we'll do so long as we don't go below 55 degrees Fahrenheit or above 75 degrees Fahrenheit.
This is the whole schematic for the whole system of Terrarium. If you look at the schematic at the top part, we have something called the power plug, which is basically nothing but a socket, and we'll be getting 110 volt 60 hertz AC signal out of it. From there, the first sector that we're going to look at is the AC/DC converter, which basically consists of a transformer, which reduces the AC volt from 110 to 12 volt, and the diodes will rectify the signal, along with the capacitor, which basically filter out the signal and makes it into a 12 volt DC. From there, the 12 volt DC gets into the voltage regulator, which later gets converted to 5 volt DC, something which all the electronic components can use. And we have also added the bypass capacitor to remove any excess frequency. So we have also added a power indicator, which you can see right above the Arduino. It basically shows whether the Arduino is being powered or not. So from the Arduino, so basically Arduino is the brain of the whole system because it acts as a computer and it's a microcontroller. We will be coding some of the things to control all the sensors in the whole system, and then we will also add something called XP Sheet S2, which is a wireless module, which will send data to our computers wirelessly. And we have 2 sensors below the Arduino, which is the soil pH and temperature sensor, and then the humidity and temperature of the air inside the terrarium. Very, very crucial sensors. Those will be connected to a 5 volt power supply, and then the other arm will be connected to Arduino so that we can get data from them. And then finally, we have 2 LED strips, which we can control each of them simultaneously. and then later we have the muffin fan, compressor, and inline duct fan, which will get powered by the 110 volt AC signal, and all the data will be gathered using the Arduino. See the final connection up there.
So what makes the Terminus unique? The Terminus was designed to control the humidity and soil moisture in order to reduce the risk of bacterial or fungal infection. It does this primarily through its humidity system. Now, what's unique about the Terminus is that for its size, not many other projects have used a humidity system in order to reduce the humidity of the system. Most systems rely on increasing airflow in order to reduce fungal or bacterial infection. However, that does nothing about the humidity, and many of them still encounter bacterial and fungal issues. So the Terminus is also designed to reduce outgassing. All of these parts are standard, which makes them cheap. However, they were also carefully chosen so that they would not release VOCs, volatile organic compounds. So all of our metal will be baked, and the rest of our parts don't outgas. We also have sensors that are integrated into the system that will provide real-time data. This data will not only help control the environment, but it will also alert the people who own the terrarium of what's going on inside. So you can know what's going on inside the terrarium, even if you can't physically see into it. That leads us to our final differentiating feature. It's a fully enclosed environment. So that means that unlike most projects, it doesn't need to be regularly opened. This is something that you can just plant the seed and forget until a few months later when you harvest. So in the future, we want to continue to develop this system and adapt it to other varieties of crops. We also want to scale up the design in order to grow more crops and take advantage of the economies of scale in order to feed people entirely off of these products. We also want to offer repair and replacement parts for all of our products as well. Finally, costs. So our humidity system is the most expensive system at $570. The rest of our systems altogether are $410. This leads to a total cost of $980 for our first working prototype. Should we be awarded more money, we would continue to create more iterations of this design and work towards our dream. Thank you for listening to our presentation. I hope you enjoyed it, and we're the Terrarium for Mars team designing the Terminus.
Thank you.
Thank you.